We are on page 78 of your interactive notebook. We're going to learn how to draw Lewis structures. You're going to have examples in your notebook for single bonds, double, triple bonds, and polyatomic ions. The directions for doing this is list the elements in the molecule. We're going to multiply each quantity of atoms by the number of valence electrons. Find the total number of electrons in the molecule. And then if it's polyatomic, you got to add or subtract according to the charge. Don't forget that you're adding or subtracting electrons. So if it's a +1 charge, you subtract 1. And then we arrange the elements in the structure. Good guidelines are carbon or oddball elements are in the center. The hydrogen and halogen is usually on the outside. We distribute the electrons in pairs and rearrange till all or most have an octet, except for hydrogen and boron, which don't need 8, or they are satisfied with 2. And then we can make double or triple bonds if not all atoms have an octet. We're going to start here with silicon or SiBr4. So the name of this would be silicon because there's a singular Si, so we don't have the prefix mono, and there are 4 bromines, so it's tetra for 4, and then bromide. Alright, let's get started. It says list the elements in a molecule, so I'm going to list Si and then Br. And then I have to look at my formula and notice there's 1 Si and 4 Brs. Following that, I have to go to the periodic table, if I don't already know. Silicon is in group 14 or 4A, so it has 4 valence electrons, and bromine is a halogen. It's in group 7A, so it has 7 valence electrons. So I'm going to multiply each of these by the number of valence electrons. I get 4 here, and this one is 28. To find the total, I need to add those together. So the total number of valence electrons here is 32. Alright, I don't have to do this step right here about polyatomics because this doesn't have a charge, so it is not a polyatomic. But I am going to arrange the elements in the structure. Carbon, or the oddball element, is usually in the center. So silicon is in the same group as carbon, so it's a lot like carbon because everything in the same group have the same physical and chemical properties. Plus it's the oddball, and what I mean is that there's only 1 Si and there's 4 Brs. So I'm going to put an Si in the middle, and there are 4 bromines, so I'm going to place 1 on each side, top, bottom, left, right. Now I'm going to start distributing my electrons. I know that these are bonded, so I'm going to give them single bonds, which are made out of 2 electrons. So I usually kind of keep track here. So if 2, 4, 6, 8, each line, keep in mind, is 2 electrons. So I'm going to subtract 8 here to find out how many total electrons I have left to distribute, and I have 24. Silicon has an octet, so I'm not going to touch it, but none of the bromines have an octet. They only are sharing 2 electrons right now, so they need an octet. So I'm just going to start putting electron pairs around them, and hopefully I get to 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I do. You might want to do this in pencil because sometimes, most of the time, this is a trial error kind of process. Good morning. So also you want to double check that you have the total number of electrons. So we need 32 here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I do have 32 total electrons in this structure, and I need everything to have an octet. Silicon does 2, 4, 6, 8. And each bromine also does, because they have 2, 4, 6, 8. So this is the Lewis structure for silicon tetrabromide.